Hello there. Hello everyone. I'm Jaira Jerika Baktul, student from Guimaras State College, Baturna Campus. Taking up agriculture, taking up Bachelor of Agriculture. Asking you to spend some time while I show you my fertilizer computation based in my understanding in our class. So, sit back, relax, and enjoy. And also, I ask for some patience and understanding for my grammar, and also for my words that are inappropriate for you. So that's it. Thank you. So here are the problems. Of rice farm of 2 hectare called for our recommended rate of 125 nitrogen, 85 phosphorus, and 63 potassium kilogram per hectare. The farmer owner sought technical assistance for you as to how many bags of fertilizers will he need to apply in the area. How many bags will you recommended for the 2 hectares area if the fertilizer available in the market are urea, which consists 14 nitrogen, 0 phosphorus, and 0 potassium, ammonium sulfate, contain 16 nitrogen, 20 phosphorus, and 0 potassium, muriate of potash, contain of 0 nitrogen, 0 phosphorus, and 60 potassium, and triple 14, contain 14 nitrogen, 14 phosphorus, and 14 potassium. If the price per bag of fertilizer are as follows: urea 1,050 pesos per bag, ammonium phosphate 900 per bag, pesos per bag, muriate of potash 1,000 per bag, and triple 14 cost 850 per bag. Okay, the formula for this given computation are the amount of fertilizer material in kilograms. It depends on the given problem if it is a sack or but in this problem the given was the kilogram, so we use kilogram. Is equals to recommended rate kilogram in nutrient per hectare times area in hectare over percent nutrient and fertilizer materials. The recommended rate for in this problem were 125 nitrogen, 85 phosphorus, and 63 potassium. To calculate the amount of fertilizer materials for 2 hectare at the recommended rate of 125 nitrogen, 85 phosphorus, and 63 potassium kilogram per hectare using a single fertilizer. So this one I'm gonna use muriate of potash. The amount of 0 nitrogen, 0 phosphorus, and 60 potassium, or the muriate of potash kilogram is equals to 63. 63 comes from the recommended rate, 63 kilograms of potassium, because we're computing potassium of muriate of potash. So let's say 63 kilogram potassium per hectare times 2 hectare. 2 hectare was the given area over 0.60. This percent came from the potassium of muriate of potash. So the percent of was 6.60 is equals to 210 kilograms. 210 kilograms of muriate of potash needed for 2 hectare. So in computation of the remaining fertilizer, the urea, the triple 14, we already compute the muriate of potash and the ammonium phosphate. To calculate the amount of fertilizer materials for 2 hectare at the recommended rate of 125, 8 ang nitrogen, 85 ang phosphorus, and 63 potassium kilograms per hectare using, we use another computation. The last time was the single fertilizer combination. This time we use a combination of complete. The triple 14 was a complete fertilizer. Incomplete, the ammonium phosphate was the incomplete fertilizer, and a single fertilizer. That was, we use urea for this one. So to start the calculation, so for this calculation, we use triple 14, urea, and ammonium phosphate. To start the calculation with the use of triple 14, always begin the computation from the lowest recommended rate. The recommended rate was 125 nitrogen, 85 phosphorus, and 63 potassium. In this recommended rate, the lowest recommended rate was the potassium, which is 63. So, always begin the computation from the lowest recommended rate. So, let's start with potassium. Using triple 14. Ang triple 14 was a complete fertilizer. So, we use ang 63 of potassium, we applied 63 phosphorus and 63 nitrogen because triple 14 was a complete fertilizer. So if you apply 63 in potassium, it's also we also apply 63 in phosphorus and 63 in nitrogen. Recommended rate of potassium and some nitrogen and phosphorus. So 125 less 63 is equals to 62. 85 less 63 is equals to 22. Sorry for the erasure. Sorry. 63 less 63 is equals to 0 kilogram nitrogen, phosphorus, potassium per hectare, or the remaining recommended rate that not sufficed by triple 14 fertilizer. So, the amount of triple 14 in kilograms is equals to 63. 63, the recommended rate. 63 potassium per hectare times 2 hectare, the given area, over 0.14. 0.14 came from triple 14. So, the 14 of triple 14 and potassium, because in triple 14 we have 14 nitrogen, 14 phosphorus, and 14 potassium. So we're gonna use 14 in potassium. So the percent was 0.14 or 0.14 is equals to 900 kilograms. To compute for the remaining phosphorus, the second to the lowest was phosphorus. So, to compute the remaining phosphorus, we're gonna use ammonium phosphate. So, ammonium phosphate contains 16 nitrogen, 20 phosphorus, and 0 potassium. So, we're gonna look for phosphorus. We use 20. We use 20 here, but the remaining recommended rate was 62 nitrogen, 22 phosphorus, and 0 potassium, because we already compute the potassium. Sorry again for the erasure. This one is 22. So To compute the phosphorus, we use 22. Well, less 22 to 22 is equals to 0. I put question mark in nitrogen because the potassium phosphate is not only containing phosphorus but also contain nitrogen, which is 16 nitrogen. So later on, we're gonna compute nitrogen contained in ammonium phosphate. But now we're gonna compute phosphorus. So let's put this one question mark. Ang 22 phosphorus per hectare ang recommended rate of phosphorus over the remaining rate not surpassed by the ammonium phosphate. So we already compute ang potassium. We're gonna compute now the phosphorus. So the remaining was the nitrogen. Later on, we're gonna know how much the remain of nitrogen here. So now let's compute the phosphorus. Amount of ammonium phosphate in kilogram is equals to 22, came from the recommended rate, 22 kilograms of potassium, of phosphorus or phosphate per hectare times 2 hectare, the given area, 2 hectare over 0.20, came from the phosphorus of ammonium phosphate, the 20. 16 nitrogen, 20 phosphorus, so we use 20 here of ammonium phosphate. 0.20, the percent of the ammonium phosphate, 0.20 is equals to 220 kilograms. The farmers need 220 kilograms of phosphorus and ammonium phosphate. So to compute the amount of pure nitrogen contained in the amount of ammonium phosphate that we will apply, since ammonium phosphate was not only contain phosphate or phosphorus but also contain nitrogen. So now we're gonna calculate the pure nitrogen in ammonium phosphate. So the pure of nitrogen in ammonium phosphate is equals to 220 kilograms of ammonium phosphate, which we compute before. In phosphorus, 220 kilograms ammonium phosphate times 0.16 nitrogen. The 0.16 nitrogens came from the nitrogen of ammonium phosphate, because ammonium phosphate contained 16 nitrogen. So we're gonna use 16 nitrogen. The percent was 0.16. This one's the nitrogen, so we're gonna multiply. S equals to 35.2 kilograms. This was the amount of pure nitrogen contained in ammonium phosphate with the 220 kilograms of phosphorus. So in the recommended rate, let's back to the recommended rate. 62. The recommended rate was 62 nitrogen, 22 phosphorus, and 0 potassium. Let's lessen the total amount of the pure nitrogen contained in ammonium phosphate will less 32.5 in nitrogen, since we already compute the phosphorus. So 22 ang less 22 is equal to 0. So that 62 of the nitrogen will less 35.2. This less the pure nitrogen contained in the amount of ammonium phosphate is equals to 26.6. This one was the remaining recommended rate of the fertilizer that was not so fast of ammonium phosphate fertilizer. So, in computing the last recommended rate, which was the nitrogen, compute for the recommended nitrogen was the 26.8 nitrogen, 0 phosphorus, and 0 potassium kilograms per hectare. That's less 26.8 nitrogen of the urea. We use urea this time. Is equals to 0 nitrogen, 0 phosphorus, and 0 potassium kilograms. All the recommended rate were also suffice. So the amount of urea, this time we use urea. Urea contains 46 nitrogen, 0 potassium, and 0 phosphorus. So the amount of urea is equals to 26.8, the recommended rate of nitrogen per hectare times 2 hectares, the given area, over 0.46, the amount of nitrogen contained in urea. The percent is equals to 116.52 kilograms. This was the farmer needed in his farm of nitrogen on his farm. This is the nitrogen needed for the farmers. So therefore, a farmer needs the following fertilizer in a following fertilizer for 2 hectares were 220 kilograms of muriate of potash, which contains 0 nitrogen, 0 phosphorus, and 60 potassium. 900 kilograms of triple protein, which contains 14 nitrogen, 14 phosphorus, and 14 potassium. 220 kilograms of ammonium phosphate, which contains 16 ang nitrogen, 20 phosphorus, and 0 potassium. Add 116.52 kilograms of urea, which contains 46 nitrogen, 0 phosphorus, and 0 potassium. Since the problem that we're gonna add, since the given problem before was not only tackled for the fertilizer, but also asked for the price per bag of fertilizer. The price per bag of fertilizer, in urea was 1,050 pesos Philippine money per bag. The ammonium phosphate cost 900 per bag, and the muriate of potash cost 1,000 per bag, while the triple 14 cost 850 per bag. While the farmer needed 210 kilograms of muriate of potash, 900 kilograms of triple 14, 220 kilograms of ammonium phosphate, 116.52 kilograms of urea. So let's compute the total cost of this fertilizer needed for the farmer's field. To compute the price of muriate of potash fertilizer per bag, since 1 bag of fertilizer is equals to 50 kilograms. So the muriate of potash that the farmers needed were 210 kilograms. Multiply, sorry. No, it's not multiply, but divided by 50 kilograms. 50 kilograms cost 50, ang 1 bag is equals to 50 kilograms. So 210 kilograms divided by 50 kilograms is equals to 4.2 kilograms, or 4 bag of fertilizer and 2 kilos. Now Now the price of the muriate of potash were 1,000. Muriate of potash were 1,000 per bag. So 1,000 divided by 50 kilograms. We already know the 4 sacks. 4 sacks since 1,000 per bag. So the 4 bag is equals to 4,000. But we need to know ang per kilograms, how much muriate of potash in per kilogram. So 1,000 divided by 50 from 50 kilograms that the bag of fertilizer contain is equals to 20 or 20 per kilogram. 20 pesos per kilogram. So the price that the farmer needed for muriate of potash were 4,040. 4,040. She needed 4,040 for muriate of potash. Now, to compute the price of triple 14, 900 kilograms, which the farmers needed for triple 14 was 900 kilograms, divided by 50 kilograms. One bag is equals to 50 kilograms. So, 50 kilograms is equals to 18 bags of fertilizer. So, the 18 bags of fertilizer were, the price per bag of triple 14 was 350. 350 per bag. So, the 350 per bag times 18 bags of fertilizer of the triple 14 was equals to 15,300. So the farmers need 15,300 for triple 14 fertilizer. Next, to compute the urea, 116.72 kilograms, which the farmers needed for urea, divided by 50 kilograms is equals to 2.33 kilograms or 2 bags of fertilizer and 33 kilograms. So 1,050, which is the price of urea per bag, 1,050 divided by 50. Divided by 50 is equals to 21. So 21 per kilo. 21 times 33 is equals to 600,093. So the price that the farmers needed were 2,793 to buy urea. She needed 2,793. And the price of ammonium phosphate, to calculate the price of ammonium phosphate, 220 the kilograms that the farmers need for ammonium phosphate, 220 kilograms. Divided by 50 kilograms. Divided by 50 kilograms is equals to 4.4 kilograms or 4 bags and 4 kilograms. So 900 were the price per bag of ammonium phosphate. So 900 divided by 50 is equals to 18 per bag. So 900 times 4, which is 4 bag, is equals to 3,600. And the remaining was 18 times 4 kilograms. Is talking 4 kilograms. So 18 times 4 is equals to 72. So the total price of ammonium phosphate were 3,672. So if we gonna add all of them, the muriate of potash, which is 4,400, the triple 14, which 15,300. Price of urea, ang 2,793, and the ammonium phosphate, which 3,672. The total amount were 25,805. These were the total cost of fertilizer that the farmers needed. So, thank you very much for spending your time in my presentation. I hope you will enjoy it, and I hope it is correct because it was only based on my knowledge. So thank you so much.